So I want to start by saying thank you everyone for coming. My name is Cody Armstrong, and today we're talking about the sketch basics in Onshape. So really intended for those just getting started, maybe with CAD or with Onshape in general, and they're trying to understand how the sketching works in Onshape, how the constraints work, all the various sketch tools that we have. Really intended for those new users, just trying to get a grasp on some of our sketch tools. As I say with these webinars, we really encourage you to ask any questions that you'd like. There's a questions dialog, and you go to webinar control panel. Feel free to type in any question. I'll do my best from time to time to stop and address all the questions. If I don't get to your question, stick around. I'll make sure at the end of the webinar to bring that over. Give me just one moment while I figure out the audio here. Testing the audio. So if anybody can give me feedback, is the audio any better or worse? Just want to make sure that I have it straightened away before we go on. Hello, hello. Testing, testing. All right, so let's move on. Forgive me with the audio. As I mentioned before, sketch basics. So really intended for those just getting started. If you have any questions, feel free to type them in the questions dialog. I'll do my best to stop and address them as we get through things. There are a few things about Onshape I like to mention in general. So for those just getting started, one thing to keep in mind is our mission statement, and that is with Onshape, we're trying to get everyone working together with CAD on any device, anywhere. And this includes mobile devices, Android phones and tablets, iPhone, iPad, and also any operating system. So Windows, Mac, Linux, Chromebooks even will run Onshape. Again, we're accessible through the browser. We're accessible through an Onshape mobile app. So you really have the ability to access your CAD data from any device, anywhere you happen to be. The other element of this is we really like to drive home the idea of working collaboratively, working together. Onshape is the first software that allows you to collaborate in real time in CAD. So you can work on the same part at the same time, work on the same assembly at the same time, and everyone sees everything update live. So again, our mission with Onshape is getting everyone working together with CAD on any device, anywhere. Now, the other thing I like to mention is we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, it's really three pieces. It's parts, assemblies, and of course you have drawings. And we do have all three major pieces that make up a professional 3D CAD system. There are a lot of things that really set Onshape apart, however. And one of the first that I like to point out is our release. So you'll see Onshape update roughly every 3 weeks. So every 3 weeks, you're going to see new functionality being added to Onshape. And the neat thing about it is from an end user perspective, you don't have to do anything. You log in and new functionality is there. There's no downloads, no installs, no updating. None of that stuff is needed from the end user. So very easy for an end user to pick up. Also, with Onshape comes built-in version control. So with a traditional file-based CAD system, you have oftentimes a data management system that goes along with it, something to manage the files, manage the check-in and out permissions, and so on. With Onshape, we have the ability to version control, and it's built into the core functionality of the software. So it was not an afterthought or a separate package or something along those lines. It was built with the intention of being a core piece of the functionality. So with Onshape, you have built-in version control. Also, we have the ability to import and export common CAD formats. So if you have a library of CAD files, SolidWorks parts, Inventor parts, CATIA, Creo, Step, IGES, Parasolid, a long list of formats, we can import and export many of those formats. So if you're looking to use Onshape maybe as a collaborative tool with your existing CAD system, or maybe you're looking to use Onshape as just a way to share with your vendors, for example. It has a lot of use cases where we have the ability to import your CAD data from your current system and then maybe share it or export it to another format. So a great way for working with vendors or collaborating with others. So we can read and write common CAD formats that are out there. And that includes, by the way, DXF and DWG. So if you have a library of 2D CAD data, we can import that as well. And as I mentioned before, with Onshape, we're introducing entirely new methods of collaboration. So simultaneous real-time editing, very similar to Google Docs. If you've ever used Google Docs and you've shared your document with someone, you can see what they're doing live in real time. So the same concept has been taken to CAD with our collaboration tools. I'm going to show you an example of this in just a bit and discuss it, but it's important to keep in mind with Onshape, we've introduced real-time simultaneous collaboration in addition to a whole bunch of other collaborative benefits. So these are just some things I like to mention about Onshape in general. What we're going to get into today, Well, as I mentioned before, the goal today is really just an introduction to sketching, getting started with sketching. What are the details to get started? What are the key things to keep in mind as you're sketching? So, of course, that means going through the sketch toolbar. We'll also be going through some relations. I'll go through a few examples of a few relation options. And then, creating planes is another example, another commonly asked question with regards to sketching. And as I'm going through this, I like to throw in just some miscellaneous tips and tricks that I found new users or help new users, get started. So kind of miscellaneous tips and tricks as we're going through things. So that's really my agenda for this webinar. I don't have a ton of slides. There's one last slide for you, and that is the sketch basics. So if you're new to sketching in 3D CAD, it really is the core of what we do. So if you think of a 3D CAD model, you start with a sketch, and the sketch is kind of the foundation for which you build all your other features. So it's important to define it correctly, and of course, it's defined using a combination of dimensions and constraints, right? Onshape is a parametric CAD modeler. We define our geometry with constraints and dimensions, so we're going to cover that. It is similar to traditional CAD applications. Now, there's some things that make it better and obviously unique, but in many cases, a line is a line, and drawing a line is very simple to do in many CAD applications, and you'll find that it's very easy in Onshape as well. So there are some similarities to a traditional CAD application like SolidWorks or Inventor, for example. And my goal with this is really just to walk you through the basics. So forgive me now if you have some experience with sketching and Onshape. We're going to start from the basics. So without further ado, let's jump into things. Now, as I mentioned before, we're going to start from nothing. So I have a new blank document up, and I want to start sketching. And one of the first and most commonly asked questions when we're talking about sketching is, what plane do I start my sketch on? It doesn't matter if I start on the front or the top or the right plane. And the answer is it's not really critical. One thing to consider is the front plane corresponds with what will be the front view of your drawing. So if you want the front view of your drawing to look a certain way, you want to make sure that the front plane corresponds. Now, again, not super critical, but just something to consider. In my case, I want to start a sketch on the front plane, right? So I can left click the front plane in the graphics, then click the sketch icon. And that's how you'll start every sketch. You'll select a plane or a face, and then you select the sketch icon. Right? That will then take you into a sketch. So you'll see now I'm in a sketch. A few visual cues. You'll see a dialog here appears giving me some feedback on the sketch. But one important step that you'll need to know is what's referred to as view normal to sketch plane. So you'll notice that I'm in a sketch on the front plane, but I'm not looking straight at the front plane. So a tip is you can right-click in the graphics and choose View Normal to Sketch Plane. That will rotate the sketch plane around so that you're looking normal to it, right at it. And definitely recommend sketching in this normal to direction just for best practices' sake. So now I'd like to start sketching. A few things I want to point out about the sketch toolbar now that we're in it. Notice that the icons have changed, right? So I have, instead of revolve, sweeps, patterns, and so on, I have lines, rectangles, circles, arcs, splines, text, convert, all these different sketch tools. So the toolbar is context sensitive, and you won't see those sketch tools until you're actually in a sketch. Right? Now that we're in a sketch, I can start creating my sketch geometry. Now I want to start with the basics, which is of course a simple line, and I want to walk through as many of the sketch icons, the sketch tools as I can, and then a few constraints in here as well. But let's start basic with a simple line. So I'll left click the line command from the toolbar, and as I move my cursor over, notice the cursor has changed to a crosshair indicating it's ready to start sketching, and I can sketch my line. Now a tip is there's actually two ways to draw a line, and it really depends on your preference. If I left click in the graphic space, move my line to wherever I want it, and left click again, I have a single line. Now the advantage or disadvantage, depending on how you view it, is by default when you do two left clicks, like I just did to create a line, it assumes that I want to draw another line. Okay? Now if you don't want that line, remember you can always use the escape key to get out of the active command. So just a tip, the escape key is very useful for getting out of a command that you no longer want. So again, two left clicks, create a simple line. The default behavior in that case is to construct another line after the last one. Okay? And if that's what you're looking for, it's a very easy way to do that. Now the second way to draw a line is instead of two clicks, you left click and drag a line out. So not 2 clicks, but left click drag. And as soon as you let go, you do not get an additional line. So again, it's really a matter of preference. I think in many situations, a lot of experienced users will use both of these methods depending on what they're doing. I'd recommend getting used to one of them until you get a feel for it, and then you can decide whether you want to use the left click drag or 2 left clicks. But it does behave just a bit differently. One will construct another line afterwards by default, the other will not. Okay. Now, one tip that I have with regards to sketching in general is here I have these 2 lines and I don't want them anymore and I want to delete them. So a few things to keep in mind. You can left click an individual piece of sketch geometry and hit the delete key to delete it. Right? So I can delete that just by hitting delete key after I've highlighted it. Or if you have a whole series of sketch geometry you want to get rid of that very quickly, you can left click drag a window. Okay, so I can left click drag a window and it will highlight everything within that window. Now the question often comes up, well, is there a difference if I drag right to left or left to right? And the answer is yes. If you have experience with other CAD applications, you'll know that the left to right drag versus the right to left will give you a different selection set, and that works as well in Onshape. But I just window selected those 2 lines, I hit the delete key, and now they're gone. Right? So it's easy to get rid of geometry if you no longer need it. So I have my lines, we've covered that. The next one in my list is the rectangle command. Now, rectangles, it's important to keep in mind, as well as many other tools in the Sketch toolbar, have drop-down menus. So you're going to see a little arrow next to the command, and it's important to keep in mind we don't have one type of rectangle, we have 2. We don't have one type of circle, we have several. So you have some variation of options for some of these commands. So if you see that drop-down menu, just keep in mind that you do have a few more options than just the default. Right? In my case, that default is corner rectangle, but if I switch it, it will remember that. So in this case, if I left click corner rectangle, and I want to place the rectangle over the origin. So as I move my cursor down, notice I get these little cues. You'll see the interface highlighting there, indicating you're creating a horizontal constraint to the origin or a vertical constraint to the origin. So you can automatically attach your sketch geometry to the correct entities. In this case, I want to attach it to the exact point, right, the origin. So I move my cursor over the origin and get that visual cue that I'm attaching it. Left click, move my mouse up, down, left, or right. It really depends on the type of rectangle that I'm creating and the orientation of it. And once I'm satisfied, I left click one last time. So again, 2 left clicks, and what you're really defining is the 2 corner locations of your rectangle, hence a corner rectangle. So from corner to corner, and you get a simple rectangle. Now, in this case, this is a corner rectangle. We also have a second type of rectangle. So let's cover that. Now, what I'd like to do, question, this is a good question. This is in regards to what I was talking about earlier. How does drawing a window over objects left to right behave differently than right to left? And give me just a moment. I'm going to have a few things on the screen here, and I'll show you an example of the differences between the 2 in that window select. So just relating to what we were talking about a second ago. So bear with me for just a moment, and I'll explain it in greater detail. So I mentioned corner rectangle. You select a point, you select one corner, you left click another corner, and you have a rectangle. It's also very easy to create a center point rectangle. So that's the second type. And, like the name implies, instead of defining by the corners of the rectangle, you define by the center of the rectangle. So very useful if you're trying to attach the center of a rectangle to something, because now I have a point I can reference. So in this case, again, I want to place it over the origin. I move my cursor over the origin, left click, move up, down, left, or right, and you'll see now I have a rectangle that's centered over the origin. Okay. Left click, and I have my center rectangle. Now, a tip, and it's a commonly asked question, is there a way to add dimensions as I'm sketching geometry? And the answer is yes. You may have noticed as I'm sketching these rectangles, these little numbers appear next to the various pieces of the rectangle. Those numbers, after you've placed the geometry, will actually allow you to enter a dimension. So I could type 8, enter, 6, enter, and now that rectangle is fully defined. So you can add dimensions on the fly as you go. If you prefer to work that way, that certainly works. But just keep in mind, again, just a frequently asked question, can you add dimensions on the fly as you're sketching? And the answer is yes. So that is a corner rectangle. Now the next one in my list are the circles. And we have a few different variations of them that are worth pointing out. The first and probably most common is a center point circle. If you've come from a traditional CAD application, this is very similar to those. You simply select the command, left click the center point of the circle where you want to place the center of the circle, then move your cursor up, down, left, or right. In this case for a circle, it doesn't really matter. And then left click again. And now you have a circle. And again, 2 clicks, first click locates the center point, second click sets the size. And of course, you'll need to go in and add a dimension to constrain it later. But that is the center point circle. Again, the main thing there is you're starting by defining the center point of the circle. The next one in the list is the 3-point circle. And like the name implies, instead of using a center point to define a circle, you actually use a series of points on the diameter of the circle. And this is particularly helpful when you're trying to attach a circle to other outside geometry. So for instance, again, in 3 points, it takes 3 clicks. So left click, and then finally one last left click to place it. This circle has 3 points on the outside diameter. And this is very helpful if I'm trying to attach this circle to other reference geometry, edges or faces or even sketch geometry. So again, 3-point circle, 3 clicks to create it. It creates 3 points on the circle that you can then attach to whatever you're trying to attach it to. So that is the 3-point circle. Now one more under that drop-down is the ellipse command. And very simple, very similar to a center point circle. You first click to locate the center point, then move your cursor to define the minor or major axis, depending on if you want a horizontal or vertical. Right? So if I wanted a horizontal ellipse, you'll see I get that snap to horizontal, or if I wanted a vertical one, I could snap to the vertical. In my case, I want horizontal. I wait till I see that visual cue indicating horizontal, then left click, and one last step is to define the height. Right? So in my case, I've defined the width. Now I need to define the height. Once I'm satisfied, left click, and now I have my ellipse. So again, very similar to a center point circle. The main difference is that additional click to define the height or width, depending on your ellipse. So that is the ellipse command. And again, all of those are available under the circle options. Also note, in my case, the last rectangle I chose was center point rectangle. Now that is the default. So it will remember the last option you chose and make that the button that stays there. And it means that if I'm always doing center rectangles and I never do corner rectangles, I don't have to go into the menu every time to select it. So now let's get into a few arcs. Now the arcs, we have a few different types that are worth pointing out. 3-point arcs, tangent arcs, and center point arcs. Actually, before I get into this, there's one thing I want to mention. This is related to a question earlier, so forgive me. I want to make sure I answer this before I move on. So let's sketch a real simple corner rectangle, and then I want to sketch a real simple circle. Okay, so we've covered both of those tools. Again, just a simple rectangle, simple circle. But the question came up, is what's the difference if I drag from right to left, right, versus left to right? Okay? And it's important to point out, right to left will select anything that touches the selection, the window selection that you've created, anything that just touches it. However, if you go from left to right, it will only select anything fully encompassed within that selection. And again, if you've come from a traditional CAD system, that's a very familiar thing. I think that's a standard in many different CAD systems. But again, right to left will automatically select anything touching the selection, the window selection you've made. And left to right will select only what's fully encompassed within that selection. Okay. All right, so let's move on. Now, what I'd like to get into next is the arcs. And as I mentioned before, we have a few different arc types: 3-point arc, tangent arc, and of course a center point arc. So we'll start with a 3-point arc. Now a 3-point arc is very similar to a 3-point circle. It's created in almost identical fashion. So again, it's 3 clicks to define it. So left click, right? Left click, and then move my cursor out, and left click again to define the size. Okay, so 3 clicks to define it, and you end up with a 3-point arc. Again, useful if you're trying to constrain the geometry, of these points, for instance, to other sketch or model edges, or whatever it may be. So it makes it easy to attach references. Now, in my case, we have a 3-point arc, but we also have a tangent arc, and a tangent arc is a very popular command. However, it's worth pointing out you can't simply create a tangent arc in space. Tangent arcs must be tangent to something. So for instance, I'm going to draw a line here. And what I want is an arc that's tangent to this line. This is a great example of tangent arc. I'll select tangent arc from the toolbar. Left click, and now I have my tangent arc. Now, at first glance, it doesn't look any different than the last arc I created. It isn't really until you start looking at it closely that you realize there's a tangent relation between the arc and the line that it's attached to. And that's essentially what a tangent arc does. It makes itself tangent to the thing that you're attaching it to. Okay? And that's also why you can't create a tangent arc on its own, because it needs to be tangent with something. So that is the tangent arc. Again, make sure that you're attaching it to some other reference, right? Some other piece of sketch geometry. So let's move on. Now the next one, a center point arc. And the neat thing about this is it allows you to define first by specifying the center point of the arc. And in the example I like to give here, let's draw another line, is let's say, for instance, that I wanted an arc from this point to this point. But I also want the center point of the arc attached to the line. And this is a very common workflow where I want to start with the arc center point and then define its size. So let's do this. We'll select the center point arc. I'll move my cursor along the line, and if you look closely, you'll see there's a point where it wakes up the midpoint. There it is. So there's the midpoint of that line. I want to attach my arc to that midpoint, so I left click, move my cursor up. I want to attach it to the top point. There it is. You'll see it actually snaps to it. Left click, and now you have a center point arc. And the neat thing about this arc is because the center point of the arc is constrained by the middle point of that line, if I change the line, the arc will automatically update, right? Because the center point is attached to the midpoint of the line. I get the correct intent, my correct design intent. So definitely worth keeping in mind. We have a center point arc, which allows you to start with the center point of the arc and then work your way out from there. All right, so that is the various arcs. Let's move on. The next one in my list are the various polygon tools. Now, there are really 2 different polygon tools, and it's not a huge difference between them. Really, the thing that makes them different is that how you define the construction circle that drives them. So let's do this. So let's select an inscribed polygon. And initially, when you place this, it's very similar to a center point circle. And so I first locate the center point, click, then move my cursor out, up, down, left, or right, depends on the orientation of the polygon. Right? In this case, I want horizontal. Now here's where it gets a bit different. As soon as I determine the size, and I left click again, you want to make sure to move the cursor in or out to determine the number of edges in your polygon. So there's one last step there. Again, I left click to locate the center, left click to define the size, and then move the cursor in or out to determine the number of edges in your polygon. Once you're satisfied with the polygon, just left click. We'll do 6, left click, and there's the polygon. Okay. Now you'll notice this is an inscribed circle to determine the polygon size. Right? Now that's the key difference between the inscribed and circumscribed polygons. It's really this construction circle that defines the geometry. So it depends what your goal is with the sketch geometry. If you want to constrain it by the inside circle, the outside circle, that's really makes the decision on what tool you would choose. So let's get rid of that. And again, I'm going to do this one more time, this time though with a circumscribed polygon, and the only real difference is where that construction circle resides. So let's do this one more time. Left click, and again, make sure to move the cursor in or out to determine the number of edges. Left click again, and there is my circumscribed polygon. And again, the main difference here is the circle, the construction circle that drives the polygon. It's on the outside as opposed to the inside. It really just depends how you want to constrain your polygon. So that is the two polygon options, inscribed and circumscribed. Now the next one is a spline. A spline is a very common tool in many CAD applications. And it's really one of those tools that, if you can get away with using a line or an arc, it's certainly going to be a faster approach. But there are some times when those shapes simply don't work. And you're looking for something a little bit more organic, something that's not easily constructed using the tools that we've covered so far. And so if you're looking for this kind of free-form geometry tool, that's Spline. Now, in general, regards to Spline, I would take a bit to understand how they behave. Because at first, it's a little difficult to understand what's going on with the spline. So let me show you what I mean. When I left-click and I start, it initially looks like a line. And it isn't until I add that second point, I left-click again, that I can start to see, oh, this isn't a line. Right? It's a free-form sketch entity. It can move in any direction, and it manipulates based on the movement of my cursor. So again, really those types of shapes where you don't have an easy way to create it using lines, arcs, or whatever the combination of those things may be. Splines give you that really smooth curvature and allow you to create some really organic-looking shapes, something that isn't easily created otherwise. A few tips regarding splines. In general, the fewer points that your spline has, the smoother the curvature will be. So you can click as many times as you'd like and create as many spline points as you'd like. However, the fewer points that you have, the smoother the transition will be between curvature changes. So if you're concerned with something like aerodynamics, for example, where the curvature is critical, you'd want to make sure to have the fewest number of spline points that you can, and that will give you the smoothest contour. Another tip about splines is you'll want to use the escape key once you've added your final point. That will exit out of the command and actually, of course, create the spline. Now, how do we constrain these things? What do we have in terms of ways of defining a spline? It's important to point out each spline has a handle. So you'll see this little point and line at the ends of the spline, and you can grab and manipulate that handle. Here's the other one on the other side. And again, I can grab and manipulate. Okay. So you have the ability to control this later. You can constrain this. You can also grab other spline points. So here's the second spline point. I can left click and drag and move that around. So you can manipulate these splines after they've been created, and oftentimes you'll need to get it just right. So you can drag and manipulate your splines. You can constrain these splines to sketch geometry. There's attaching it to the origin, for example. But again, the main thing to point out is splines tend to be a bit more tedious. They take a little bit more work, but if you're looking for that type of shape, oftentimes it's one of the only tools that you can really get it with. So that's the spline command. In general, I'd recommend spending a bit of time to understand how it behaves and how you can get the smoothest curvature. Oftentimes, users that do a lot of splines will only have 2 points, and that's the simplest spline they can create, so that's what they work with. Now, the spline command, you have these points, but a question often comes up, well, what if I wanted to add one more point to the spline? I've already created it, I've added the command, what options do I have? In the spline dropdown, there's a spline point command. And like the name implies, you click spline point, you move over a spline, and if you left click, you add another spline point. And this just gives you another point to control your spline. Okay. So again, you're not forced to create the spline perfectly when you're sketching it. Just construct it roughly and then use the various points and handles to really constrain its shape, to define its shape. So that's a tip on splines, a few tips on splines. Let's get out of that. Now the next command I want to go over is the point command. And a point is valuable in a number of different situations. Let's say, for example, that I wanted to attach a point to some other sketch reference so that I could attach that point to something else, maybe a constraint, or I want to attach my part to a point. I can select line, and let's just draw a line real quickly here. And let's just say that I wanted a midpoint right at the middle of that to constrain with another piece of sketch geometry. I can select point, move my cursor over the line, and then as I move the cursor, again, I'm waiting for that midpoint right there, left click, and now I have a point on the midpoint of that line. And this is useful because now I can constrain this and I get that symmetric behavior out of my line that you would expect. Okay. So that is the point command. Remember, you can add points to any sketch geometry. Just keep in mind that it's really great reference for something like attaching relations or reference entities from other features. So, a question: can you add a point to the end of the spline, or does it have to be in the middle? It's important to point out the spline endpoints are defined by when you start and end it. You don't add another point at the end or extend the length of it. You can grab it and move it, but you can't add a point at the end. You can add as many as you want from start to end, but you can't add a new start and end of the spline. Forgive me if that doesn't answer the question, but again, you can't add it on start and end, just any point in between the two. Okay? You really control the start and end by the two endpoints on the start and end and those handles. All right, so that is the point command. Again, useful in dozens of situations where you'd want to attach the geometry that you're looking for. I want to attach another line or another circle, let's say, to the midpoint of this line. That's a great example where I might use point. The next command in my toolbar is the text command. It's a commonly asked question. Can you create text in Onshape? Extrude it, maybe cut it, whatever you're trying to do. And the answer is yes. If you select text, you'll see a icon appear, a cursor appear, indicating it's ready to start sketching. And really, text is all determined by the rectangle that you draw. So as soon as you select text, then you draw a corner rectangle. So corner point, and then you enter your text. Okay, we'll type in Onshape. I can define the font size. Now, the font type. A commonly asked question, how come I don't see my fonts in this list? And it's important to keep in mind these are freely available fonts that will run in any browser. So we want to make sure that you have the same list of fonts, whether you're logging in from Windows, Mac, Linux, or you're logging in from another computer that doesn't have that font type. So we have a few font options. We have bold and italic, and that's it. You hit the green check, and it fills the rectangle with the text that you've specified. Okay. Now, the rectangle really defines the text, not just its location, but also its size. I can dimension the rectangle and say, okay, this is 12 inches, and that will define the size of my text. I can move the rectangle around by deleting the constraint to the origin and dragging it around. So really, the rectangle is how you define where the text goes and what size it is, and then it just fills it with the text that you're looking for. Question. How can I draw a line and size rectangle and rotate it by a specified degree? Well, it's important to point out, let's jump back here. As I'm sketching, for instance, if I wanted a line at a certain angle, I could just simply draw a line at that angle. Now, the question is, how do I know what that angle is? And inevitably, that will mean you'll want to constrain it to something. You could dimension it to, for instance, a plane and add a plane dimension of 45 degrees, for example. That will give you a 45-degree line. Rectangles, however, are a bit of a different story. If I sketch a corner rectangle, by default, it assumes I want the rectangle to be horizontal. However, if you mouse over one of the lines, you'll see that I have these options for perpendicularity and parallelism. You can grab and drag and delete these constraints for parallel and perpendicular and move or manipulate the rectangle around. So it will require you to go in and edit the constraints, but just keep in mind that is an option as well. Okay, so the next one in my list, real quickly, question. I code you about units. I'm in the UK. How can I default to millimeter rather than inches, please? Very good question. So the question is, how can I default to metric units, millimeters, instead of inches? So a bit of an aside, if I go to the top right corner here, under my name, manage account, you'll see preferences. If you set the units here, it will set the default units for all future documents. Now, this doesn't change the existing documents that you've already created. I can show you how to do that. but this will change the defaults. So if you prefer metric units, set it to millimeter and hit save, and you're off and running. All future documents will be in those units. So the other question is, well, what about a document I've already created? And the answer to that is you'll find the workspace units under the document menu. So in the top left corner, you'll see these 3 lines, the document menu, and you can choose workspace units and change the units there. All right, so the next tool in my list is convert, and it's often referred to as convert or project. We refer to it as the use command in Onshape, and it allows you to take existing sketches and features and edges and faces even and convert it to sketch geometry. Now, the example I like to give here, let's sketch a simple shape. Let's sketch a corner or center rectangle, center point rectangle, and I'll sketch a tiny little circle in the middle. Now, what I'd like to do is, of course, take this and extrude it. So we'll create a real basic extrude, right? 1 inch, that looks good. Green, check OK. So at some point, you're going to create a feature, and then you're ready to create your next feature, right? I'm ready to create, let's say I want to create an offset of this circle and extrude that out. I'd start a sketch on this face. Remember, you can use any plane or a planar face, a flat face. So I'll left click the face, hit the sketch icon, and again, right click, view normal to sketch plane. So again, those 3 steps, select the plane, select sketch, and right click view normal to sketch plane are very important. But now that I have the sketch geometry and I'm ready to start sketching, a thing I want to point out about this is oftentimes a new user will then start with a circle and sketch the circle and then dimension the circle and so on. And the important thing to point out about that is it may not necessarily reflect your intent. What I really want here is I want a circle the same exact size as the previous feature, and I want an offset of that circle a certain amount. If I go in and add dimensions to this, it does not constrain it in that way. So a tip, you can select the use command from the toolbar, left click the circle, and it converts that edge to sketch geometry. To show you what I mean, if I hide the part, notice I have a sketch circle there. And I didn't sketch that circle, I simply used it from a previous feature. The neat thing about this is if I change the original circle, this sketch will automatically update. So I'm building a bit of design intent into my model, and I'm making it so that when I make a change, I don't create this domino effect of errors that I have to rebuild because I've correctly reflected my intent. So just a tip, the use command is very valuable for converting faces or edges or even other sketches to the current sketch. And it allows you to reuse geometry in an efficient manner that allows you to reflect the intent. So let's move on. Now, a quick question. Can you format text and dimension text ahead of time for the default font and size? And the answer is no. As of today, you select text, you draw a rectangle, and then the rectangle defines it. So it is in a certain order. You select the command, then sketch a rectangle. You can't do it the other way around. Now, that is the use command. Now, tying in with this example, another thing that I'd like to show is the offset command. Offset, like the name implies, allows you to grab existing edges or sketch geometry and offset them. Now, in my case, what I really want is an offset of this circle we created a second ago. So I select offset, left click the circle, and now I have an offset of that circle. I can left click the arrow and drag it to dynamically resize the offset. But as soon as I let go, I have to enter a value. So what kind of offset do I want? I want a 1/2 inch offset, and there we are. Now I can take this and extrude it, and I've created that round boss offsetting the hole in the middle. Now you may ask yourself, well, I could have just drawn 2 circles there and dimensioned them. The answer is yes, you could have. However, if you make a change, those features, because they're driven by single dimensions, they do not update. So let me show you what I mean. Let's edit the first sketch, and I'm going to change the diameter of this circle to something much bigger. Now, if I had constrained that circle, the second feature, using dimensions, that feature would not update. But because I've selected the use command and I've converted the edges of the previous features, the circle for the second feature automatically updates. So again, just trying to build that design intent in so that when you do make a change, it doesn't create a whole list of errors and things that you have to go back in and manually correct. So again, that's just a tip on the use command. It allows you to take existing sketches or edges or faces of previous features and reuse it in the current sketch. Okay. So let's move on. Well, the next one on my list is construction. And like the name implies, it allows you to take any sketch tool and convert it to construction geometry. So for example, if I want a construction line, and those who are not familiar with the term, construction means it's there for your construction, but it does not get used when you create a feature. So if you ever want to create geometry just for the sake of constructing other lines or circles, whatever it may be, use construction geometry. When you go to create your extrude, revolve, sweep, or loft, it will be ignored by the feature. So an important tip, construction geometry. Now you can select any geometry, lines, circles, rectangles, whatever it is. So I'll select a line, then click construction, okay? Then left click, and now I have my construction line. And it doesn't matter whether it's circles or arcs or any of those types of commands, you simply select the tool, then you select construction. Now the question often comes up, well, what if I already have a line? And the answer is you can convert entities to sketch geometry. Left click the geometry, left click the construction command. And that will convert existing sketch geometry into construction geometry. Okay. Could you show how to use the intersection command? And this is a very good one. I don't know that I have a great example. Forgive me if I kind of make one up here. Give me just a moment to think of an example here. Let's do this, and this. And let's take this. So bear with me for just one moment. Revolve, and let's revolve this around that. Okay. Actually, you know what? That will not do. Actually, let's do this. Let's sketch. Let's edit the sketch and move this over. There we go. Okay, so let's extrude, real simple shape. What I want to do is show you the intersection command, and the key thing with intersection is it takes existing faces or of the model, it could be organic faces or anything like that, and converts it to sketch geometry. And the key thing is it does it about a plane. So if I do a sketch, I can choose the intersection command and select my geometry. In this case, this face. And it will select where my current sketch plane intersects that face or entity that I'm selecting. So now you'll see I'm on the right plane with a sketch, and I'm converting edges, that I don't really have edges here, but just where my part intersects that plane. Okay. The key thing there, select the intersection, select the faces, and then anywhere that face intersects your plane, a sketch geometry, some sketch geometry will be created. Okay. All right. So the next one in my list, real quickly, a question. Can you convert construction geometry to build geometry? Yes. It's the inverse of converting it to construction geometry. So select the construction line, click construction, and it does the opposite. It converts it to regular solid geometry. So that is construction command in the toolbar. You'll see it right here. The next one is a sketch fillet. So let me show you an example of this. Now let's start with a center point rectangle. Just draw a simple center point rectangle. And of course, what I want to do is I want to radius these sharp corners. Now, of course, we have a feature fillet. Like many 3D CAD systems, you can radius a 3D corner with a fillet command. But we also have a sketch fillet. Now, a few tips for sketch fillet. It's very easy. You just simply click a point, enter a radius, and it adds the radius to that point. So it's very easy to do. And the neat thing about this also is if you keep going, if I left click another point, it just assumes that I want the same radius value. So if I want to add a whole series of half-inch radiuses to this model, I can just keep clicking points, and it keeps adding sketch fillets to each of those points. But another tip, and this is just another frequently asked question, What if I don't know the size, but I just want to kind of eyeball it? I want to drag it and see what happens. You can also, instead of left clicking a point, left click and drag, and you'll get a dynamic preview of the sketch fillet. So if you don't want, something close to right about there, let go. Okay, that's about 1.875, right? It's useful if you're trying to eyeball the size of the radius, or you're trying to get it to, maybe to match other geometry close to it. You don't have to left click a point and enter a value. You can left click drag. Of course, you still need to enter a value, but it allows you to dynamically resize the fillet and kind of get it close to the size you're looking for before you actually, create it. Now, as I mentioned before, if I keep going, if I click another point, it just assumes that I want to keep adding the same radius size. In fact, it adds an equal constraint between all those radiuses. So if I decide to change one, they all update. So that is the sketch fillet command. Again, you have the left click a point or left click drag, and you get that dynamic resizing of the sketch fillet. Now, another frequently asked question that often comes up is, what about something like offset, where I want to offset more than just a single line, or a single piece of geometry? I showed you earlier we can offset a circle. But what if I wanted to offset all these lines and arcs? Oftentimes a new user will select offset and then come in and left click a whole series of entities one at a time. And you can imagine, with something like, a dozen line or even 100 lines, that can be a very tedious thing. I don't want to sit there and left click all the individual entities one at a time. So I can select offset, and instead of left clicking individual pieces, again, use that left click drag. And if I left click drag, it will automatically offset the entire chain of sketch entities instead of just the individual piece. So very useful if you have a lot of sketch geometry you want to offset at once. You don't have to left click each piece, left click and drag, and you get an offset of the entire chain. So that is, again, just a tip on the offset command. Okay? And also, by the way, as well, sketch fillets. A question. I'm never sure to fillet in sketches or on 3D extrusions. Do you have guidance on this, please? And in general, this is something that you'll find that some people argue about internally. Even amongst experienced CAD users, should you create a fillet in the sketch level, or should you create it in the 3D level, in the feature level? And the answer to that I often give is, if you have an edge that's filleted the same radius in several places, I would often do a feature level fillet. It allows me to click a fillet and click on several edges and have them all tied together. Now, if everything is in one sketch, it really doesn't make a big difference, because I can then fillet every edge in the sketch and use it. But when we start talking about 3 and 4 and 10 and 100 features, and I want to fillet 5 edges from other interrelated features, I'd probably use a feature level fillet. If everything's in that one sketch, I'd probably use a sketch level fillet. But it's important to understand that even experienced CAD users will sometimes disagree about that option. So it sometimes can boil down to a matter of preference more than anything else. Can you modify one of the existing fillets without affecting the others? And it's a very good question. By default, forgive me. Let's start a new one. By default, if I do this, okay, and let's do a sketch fillet and go point, okay. So now I've got these sketch fillets in place, okay. It's important to point out, by default, it assumes that you want them the same size, and it does this with an equal constraint. So as I mouse over that arc, you'll see this little equal constraint appear. You can delete that constraint, and that will allow you to modify one and not change the others. But by default, it assumes that they're all equal. If you keep clicking points, it will keep adding radiuses at the same value, and it will tie them all together with equal. If you decide later on that you want to change the size of one, just delete that equal constraint and then add the appropriate dimension in. All right, so let's move on. Now, another one that I want to cover is the slot command. Now, a tip for slots is it's referencing some other sketch geometry. So let's start simple. Let's sketch a line. And then I want to select slot and left click the line. Okay. Enter my radius size here. Let's say 0.75. And now I have a slot around that line. So if you're looking for a slot, very easy to do. The neat thing I like to point out about slots is it's not specific to lines. I can take a spline, for instance, do a slot, select it. Now I have a slot around my spline. It could be arcs. It could be all kinds of cool stuff. So just keep in mind, you can create slots around other sketch geometry besides lines. It could be arcs and splines and so on. Now, another frequently asked question. Let's sketch a circle real quickly. Can I take an individual piece of geometry and split it into multiple pieces of geometry? And this is particularly helpful for things like a loft, where I want the same number of vertices on each sketch point. I can select a command like split and split the individual pieces of the sketch. So now I've split that, and now this circle is actually two different pieces. I have an upper piece to the circle and a lower piece to the circle. So you can take what is a single piece of sketch geometry and split it into multiple pieces. I found that it's most common in loft, but of course there are many scenarios where you might want to split a piece into multiple pieces. So, all right, so we are coming close to the end here. What I'd like to get into now are the dimensions and constraints. So let's get into this. Now let's start with a simple rectangle. And of course, as I mentioned before, you can enter a dimension as you're sketching. So if that's the way you like to work, just enter a value. As soon as you're done, hit enter, and it will constrain it. However, if you don't enter a value as you're sketching, you'll need to add something that defines the size. Remember, we're constraining this sketch via dimensions and constraints. So in my case, I want to dimension this rectangle. I select the dimension command from the toolbar. Left click the line that I want to dimension, in this case this horizontal line, move my dimension to where I want to place it, left click, and then enter a value. Let's say 8, enter, and now that width is defined. And you'll actually get visual cues. Notice that the lines on the left and right are black, but the lines on the top and bottom are blue. Black lines equal a fully defined sketch entity or sketch. Blue lines equal underdefined. And the big thing here, you can even drag and resize, okay? And I can move things around. So I can manipulate these if I wanted to, or change the value and have it dynamically resized. One of the best ways to see why your sketch is underdefined is just to left click and drag the entity, and you'll see it move. Now, your goal with each sketch should be to fully define it. It means that it's correctly reflecting your intent, and it makes incidental changes harder. Right? And if you ever have a scenario where it's underdefined, you can make a change and not be aware of how it impacts other things. If it's fully defined, the user is forced to delete something if they really want to change your sketch. So it's much more intentional. So again, our sketch is our sketch goal here is to fully define it. So we'll add one more dimension. Okay, left click. This time we'll add a value of 7. And now notice the entire rectangle is black. So the entire rectangle is fully defined. Now, much of what I've done here is automatically constrained. So you'll notice that I didn't add a single constraint manually. I just added 2 dimensions, and now I have a fully defined sketch. And that's because much of the constraints are automatic. So if you check this Show Constraints box in the Sketch toolbar, or in the Sketch dialog, you have these sketch icons. And these icons are the various constraints. So I can see a parallel constraint between these 2 lines, parallel between these 2, perpendicular between these 2 lines, horizontal. I mentioned before you can delete the horizontal constraint of a rectangle and rotate it at an angle. You would delete that constraint and then grab and drag it. So you have all the constraints automatically created. You can see them by checking Show Constraints. Now, there will be scenarios where you need to manually add constraints. So let's walk through that. So in this case, let's draw 2 simple circles. Okay, I want one circle there, one circle just horizontal to the right of that one. And what I want to do is join these with a line. So I select line, move my cursor over the circle. Notice I get that visual feedback. Again, it's snapping to the circle, so I'm automatically creating the constraint. So I go line, well again, move my cursor over, notice it snaps to the other end, and if I move it just right, I get coincident and tangent. Okay? So now that line is tangent. We'll do this one more time. Okay? line, line, and now I'm getting closer to a fully defined sketch. As I mentioned before, though, it's not completely constrained, right? So if I go in and add, let's just add a few dimensions here. We'll define a distance between these 2 points, let's say 12. So now as I start to constrain this, again, you get the visual cues. This circle is black, this circle is black, but the lines are not, right? These lines that join the two are not fully defined. And if I left click and drag them, you'll see they're free to float. What I really wanted here is this line tangent to this circle, but it did not automatically do that. So I have to go in and add that constraint. Now, as I mentioned, many of your constraints will be automatic, so you won't have to do this all the time, but there will be those scenarios where you need to go in and add the constraint yourself. To do that, simply click the geometry you want to reference, in this case, line, circle, then select the relation from the toolbar. You'll see tangent, I select tangent, and now I have the line tangent to the circle. Also notice that line is now showing up as black. Okay, so again, let's do that one more time. Left click the line, left click the circle, then select tangent. Okay, so again, we're using a combination of dimensions and constraints. Now I've gone to a fully defined sketch here with 3 dimensions and a few manual constraints that I had to add. And now I can take this and turn it into, a 3D feature, and extrude, revolve, sweep, loft, whatever it is that I'm trying to accomplish. But again, visual cues, and the key thing with our sketches is we want to make sure that we're correctly constraining them and that they correctly reflect our intent. So we have just a couple minutes left. I want to take this opportunity to answer any questions that are outstanding, so feel free to ask them. Real quickly, going forward, if you're just getting started on Onshape, we really encourage you to try Onshape in your professional environment and let us know what you think. There's a feedback tool. It's in the help menu, so the question mark menu in the top right. If you click that, you'll see feedback, and we've tried to make it very easy for you to give us feedback. And also, this is a great way for us to prioritize future features, and really, whether it's you want this feature, or I have this bug, or I have something along those lines, the feedback tool is useful in all those scenarios. So again, really encourage you to give us feedback, let us know what you think, and also share your document. There's a share icon on the top right. Remember, you can collaborate in real time, you can communicate via comments, you can see each other's screen with follow mode. So all kinds of cool stuff comes from sharing your document. By default, everything you create in Onshape is private to you. No one else can see it, but if you want to share, you certainly can, and again, you get all the benefits that I was just talking about. So that is it. Again, I know there are a few outstanding questions. I'm going to get to those in just a moment, but thank you, everyone, and have a good day.